Hey mathematicians, Justin here. Check it out. My local library is having a guess how many candies contest. They have this container full of gumdrops and they're asking for patrons to guess how many total gumdrops there are in the container. The person who guesses closest wins the whole jar and a whole basket of reading goodies. We've learned a lot together about 3D figures so far. Do you think you could help me figure out how many gumdrops are in the container? What kind of figure does this candy jar look like? Yeah, this jar is actually a triangular prism. We've worked with prisms like this before, but so far we've learned about surface area, which is the amount of space on the outside of a figure. But these gumdrops are inside the container. The space inside of a 3D figure is called the volume. But how can we figure out how much space there is inside of a prism? In other words, how do we calculate the volume of a prism? Imagine extending the base and giving it height all the way through the prism until it reaches the opposite base. That's the volume. We call this distance between the two bases the height of the prism. How can we turn this into a formula for the volume of a prism? Well, to find the volume of a prism, you take the area of the base and multiply it by the height of the prism to represent the space being filled in between the two bases. We write this as V equals big B times big H. Big B stands for the area of the base of the prism, and big H stands for the height of the prism. We haven't seen too many capital variables so far, have we? Why do you think the volume formula uses a big B and a big H instead of a lowercase b and a lowercase h? Well, lowercase b and h already have a different meaning. We use little b and h to represent the length of the base and the height of a 2D shape. Big B and big H have a different meaning, so even though they look similar, they're not the same variables. Let's practice finding the volume of a couple of prisms before we try the candy container. Example number 1 says to find the volume of the triangular prism. To do that, we need to use the volume of a prism formula, V equals big B times big H, which says to multiply the area of the base times the height of the prism. We'll start with the area of the base. Which faces of this prism are the bases? In a prism, the bases are the same, or congruent, and parallel. So these triangular faces are the bases. That means that for this prism, big B, the area of the base, will be the area of this right triangle. Pause the video and find the area of the base now. To find the area of a triangle, I need to do 1/2 times the base times the height of the triangle, or 1/2 times little b times little h. Remember, a triangle's base and height have to form a right angle or be perpendicular to each other. Since these two edges or sides of the triangle meet at a right angle, they are the base and height of the triangle. Using our area of a triangle formula, we get that the area is 2 inches times 3 inches, or 6 square inches. All right, we have the area of the base. That's one part of our volume formula complete. What's the height of this prism? The height is the distance between the bases. Since these two triangles are the bases, the distance between them is 9 inches. If we wanted to fill up this whole prism, we can imagine stacking this triangular base together over and over again until it fills up that whole 9-inch height. Mathematically, we show that by multiplying the area of our base, 6 square inches, times the height, 9 inches, to get a volume of 54 cubic inches, or 54 inches cubed. Since volume is a three-dimensional measure, our units should be cubed, or raised to the third power. Another way to see where these cubic inches come from is to look at our entire calculation altogether. We're multiplying inches together 3 times, which makes inches cubed. Now, we can be confident in our numeric answer and our units. Example 2. What's the volume of this rectangular prism? We'll need to use our formula, V equals big B times big H, which requires multiplying the area of the base times the height of the prism. Pause the video here to identify what is the area of the base and what is the height of the prism. Actually, since this is a rectangular prism, there are multiple faces that could be the base. These two faces are the same and parallel, so these could be our bases. In this case, the area of the base is 5 times 2, or 10 square millimeters. And then the height would be the distance between these faces, 12 millimeters. But that's not all. These two faces are also congruent and parallel, so I could use them as the bases. In this case, the area of the base would be 5 times 12, or 60 square millimeters, and then the height would be the distance between these faces, 2 millimeters. Are those the only two options for which faces can be the bases? No! These two faces are also congruent and parallel, so we could consider them our bases too. If these were our bases, then the area of the base would be 2 times 12, or 24 square millimeters. And the height would be the distance between these faces, 5 millimeters. Do you think it matters which option you choose for the base? Will using the different base options give us different volumes? No. No matter which base and height pair you use in our calculation, their products are equivalent. So you still wind up with the same volume no matter what, 120 cubic millimeters. Nice, we've successfully found the volume of this rectangular prism, not just once, but in 3 different ways. Now that we're confident in our volume calculating, it's time to win that contest. I took some measurements of the jar so that our calculations are accurate. I think you're ready to try this on your own. Pause the video here and find the volume of the triangular prism candy jar now. The bases are these 2 triangular faces. To find the volume of this prism, we need to find the area of one of these triangular bases, big B, and multiply it by the height of the prism, big H. What is the area of the base? To find the area of the triangular base, we have to do 1/2 times little b, the base of the triangle, times little h, the height of the triangle, which makes 1/2 times 21 times 18.2. First, we'll multiply 1/2 times 21, which is the same as doing 21 divided by 2. Then we'll multiply 10.5 times 18.2 to get an area of 191.1 square centimeters. So, the area of our base, big B, is 191.1 square centimeters. We still need big H though. What's the height of this prism? The height is 5 centimeters since the 2 bases are 5 centimeters apart. Let's finish up by multiplying big B times big H. The volume of this prism is 955.5 cubic centimeters. Wait a second. We found the volume of this triangular prism candy jar, but that's not what the contest asked for. I still have to figure out how many gumdrops can fit this 955.5 cubic centimeters of volume. But that's okay, because I know you'll be able to help me with that too. Check out the bonus after your guided notes to help me figure out how many gumdrops can fit in 955.5 cubic centimeters. Today, we were able to figure out that to find the volume of a prism, we can use the formula V equals big B times big H, or volume equals the area of the base times the height of the prism. Thanks for all your help. Be sure to complete the rest of this lesson and check out that bonus to help me figure out how many gumdrops there are and win the contest. I'll see you next time. Hey.